All right, welcome to lesson 6-4, Quadrilaterals. Today's learning target, I can identify quadrilaterals based on their side and angle characteristics. Yesterday we talked about triangles and how we can classify them by their sides and their angles. And remember we said with triangles, it's almost like they have a first and last name, right?
Yes.
Okay, because we can classify it, we can give them two names. So quadrilaterals can have two names and sometimes more than two, depending on the quadrilateral. So in order to be successful today, I must understand that each quadrilateral has its own unique characteristics. So just to begin, we're going to look at two very common quadrilaterals. And the first thing, as I tell you these are quadrilaterals, what do you think a quadrilateral is? What is it, Jackson Bader?
It's a shape that has four sides.
It is just a shape with four sides. Any four-sided figure is a quadrilateral. Here I have two very specific ones. So we're going to look at squares and rectangles. So what do you notice about the sides and angles of each one? What do you notice? Winston?
That they both have four angles and four sides.
Okay, so angles, sides. So both of them have four of each, right?
Yeah.
What else? What else do you notice, Kenzie?
I noticed that both of them have four right angles.
Oh. So if we want to be even more specific for our angles, we could say each of those has four right angles. So there are square angles, right? How many degrees is a right angle?
90.
You guys are so smart. Awesome. Okay. What else do you notice, Cody?
I noticed that they're all enclosed shapes.
They are all closed shapes. I love that you noticed that. Izzy?
They're both parallelograms.
Ooh, what is a parallelogram?
It's a shape with at least two parallel sides.
So, isn't it a good thing that Mrs. McElroy taught you guys about parallel sides the other day? It's kind of coming in handy. So, if I look at my square, I notice this side and this side are parallel. They're never ever going to intersect, right guys?
Yeah.
And then if I look on the other side, these two lines are never going to intersect, which means if I have a shape and all of its sides are parallel, like this square, then it is called a parallelogram. And our rectangle is also a parallelogram. Okay, so let's move on. So the definition of a square. In order to be a square, it has to have four right angles and four equal sides. A rectangle also has to have four right angles, but the difference between a square and a rectangle is the opposite sides have to be equal in length. So, is every square a rectangle?
Yes. Yes. No. Yes. Yes.
Is
Yes.
every rectangle a square?
No.
Okay, so every square is a rectangle, but not every rectangle is a square. Okay, now we're going to look at the rhombus and our lovely parallelogram. What do you notice about the sides and angles? Lauren, what do you notice?
On a rhombus, it has 4 acute angles.
So here's our rhombus. I see this acute angle, but this one I think is obtuse. And so is that one.
So there's square. 2 acute and 2 obtuse.
And 2 obtuse. Okay, oh, let's raise our hands. Okay, what about the parallelogram? What do you notice about those angles? What do you notice, Sam?
That there's still 2 acute and 2 obtuse.
So, just like the other one, it also has 2 acute and 2 obtuse. Aren't you glad Mrs. McElroy taught you about acute and obtuse angles the other day?
Yeah.
Coming in handy. All right, what do you notice about the sides? I'll do it in blue. Okay, Kira, what do you notice about the sides?
I noticed about the sides for the rhombus and parallelogram that they're both slightly tilted, and the rectangle sides are longer on a different side, but the side ones that go parallel down are the same size.
You know, I'm really glad you brought up that word parallel. Does a rhombus have parallel sides?
Yes.
Are all the sides parallel in a rhombus?
Yes. Yes.
Can a rhombus also be a parallelogram?
Yes.
Is every parallelogram a rhombus?
No.
Explain. Addison.
So every rhombus, so you could have a quadrilateral that could be parallel or a square that's parallel, but in those shapes they're not a rhombus.
Okay, what makes a rhombus so special that it gets its very own name? What makes a rhombus so special, Jake?
That all the sides are equal.
Oh, did you guys notice that all the sides are the same length
Yeah.
on a rhombus?
Yes.
But a parallelogram,
They aren't.
they are not. Let's see what our next slide says. So here's our definition of a rhombus. All sides the same length, opposite sides are parallel. So it has to be a parallelogram. A parallelogram is just any shape whose opposite sides are parallel, and the opposite sides, guys, have to be the same length. So if I look at this one, this side and this side, did you notice they're the same length?
Yes.
If they're not the same length, it's not a parallelogram. It's going to have a different name. Then did you notice this side and this side is the same length?
Yes.
Okay, so parallelograms have parallel sides that are equal in length. Okay, we're going to look at the next slide. This is our oddball, a trapezoid. Beckett.
A trapezoid is the only quadrilateral that is not also a parallelogram.
Okay, it is not a parallelogram. Hold on, let's investigate. Sounds like we're not sure. A parallelogram, I know all sides are parallel, right?
Yeah.
Okay, when I look at a trapezoid, it does have one set of parallel lines. Each of these trapezoids do. Okay, now watch this. So it has one set of parallel. Now I'll use red, and let's see. These are going to intersect, aren't they? Okay, what's going to happen with, mean, I need a big piece of paper, but do you see how they're going to intersect? They're not parallel.
Yeah.
And then this one kind of turns into our isosceles triangle. But, yep. Okay, so it is not a parallelogram. It only has one set of parallel lines. What do you notice about the length of the sides? What do you notice about the length, Sophie?
None of them are actually the same equal. None of them are equal.
Not all four, right?
Yeah.
Okay.
Some like that, like the one on far right is all the sides are not equal.
So do the sides have to be the same length?
No.
Not in a trapezoid. I'm looking at our examples here, and just by chance, well, we could see this one's shorter than this one, right? I think this side and this side is the same, but it doesn't have to be on a trapezoid.
It doesn't?
Nope. This one we could see that this one is longer than this one. And then these two are probably about the same, but they don't have to be. And these might be the same. This is shorter than this one. So trapezoids are kind of the ugly duckling of the quadrilaterals because they don't have those nice, neat right angles. As a matter of fact, do you see any right angles?
Yes.
Go point at it. Okay. Moving on. Oh, here's our actual definition. Only one set of parallel lines, sides may or may not be equal. So the trapezoid is kind of what we call all other quadrilaterals, besides squares and rectangles, rhombuses, and parallelograms.
Sad.
All right, today you learned all about
Quadrilaterals.